Okay, gentlemen, welcome to 5.6 day 1. Factor a perfect square trinomial, or short form PST, and factor a difference of squares, DOS. We've had some experience with this already in completing some of our factoring lessons in this chapter, so this should be fairly simple. Which one of the following values of k makes the trinomial 4x squared plus kx plus 25 a perfect square? Well, to be a perfect square trinomial, so we have a perfect square here. 4 is a perfect square, and so is x squared. And 25 is a perfect square. So our first term and our last term are both perfect squares. Now, when you factor a perfect square trinomial, it looks like vertex form. So in this case, the square root of 4x squared is actually 2x, and the square root of 25 is a positive 5. And you'll notice that both the middle term is positive. Both the middle term is positive and the last term is positive. So we're dealing with addition. That's why I know it's for sure I'm dealing with addition here. Okay, so if I were to factor this, or sorry, expand this, I'd have 2x plus 5 times 2x plus 5. So it would look a little bit like this. Let me switch that up. Times 2x plus 5. And if you FOIL, you have 2x times 2x, which is 4x squared, and then 2x, so 4x squared, and then 2x times a positive 5, which is 10x, and then 5 times 2x, which is another 10x, and then 5 times 5, which is positive 25. So our middle term is actually going to be made up of positive 10x plus 10x. In that case, the middle term would be 20. So D is your correct answer there. Choose the expression that's equivalent to a squared minus b squared. This is a difference of squares. Very simple to recognize the difference of squares because subtraction, the proper way of saying this, is a difference between two numbers. And in this case, we have a squared, perfect square, and b squared, perfect square. So it's a difference of squares. And you'll notice in a difference of squares, the difference between a difference of squares and a perfect square trinomial is that a difference of squares is a binomial. And a perfect square trinomial obviously is a trinomial. So in this case, which one of these will give us no middle term? Or how would you eliminate the middle term? Well, we know a minus b squared looks like vertex form, so that must be a perfect square trinomial. This must be a perfect square trinomial as well. And this is not a difference of squares, it's a squared plus b squared, and that would not be equivalent to that. That one's a little bit more common sense. And so we're left with b. And to show you why B is the correct answer, let's take a look at this. We have, if you did A times A, you'd have A squared. If you were expanding this, you'd multiply or FOIL, and A times B would be positive AB. And then this negative B times A would be negative, let's write it in alphabetical order, negative AB, and then negative B times positive B would get you negative B squared. In this case, you'd be left with a squared if you simplify, a squared, and the positive ab minus ab cancel each other out, and you're left with minus b squared. So B is the correct answer because by having the addition and subtraction, or in this case subtraction and addition, a minus b and a plus b, the middle term is eliminated. For this third question, I just went ahead and input a chart. So take a look here. Is the area of a circle always greater than its circumference? And the answer is no. And so I made a chart. I'm using 2 pi r for the circumference, and of course pi r squared for the area. I could use pi d for the circumference, but since I'm already going to be using r for the formula of area of a circle, I'm going to use, why not use 2 pi r and use the number once. So I use the same number once here. So I 1, and if I sub that in for radius into the formula 2 pi r, let's take a look here. I have 2 times pi times 1. I get 6.283. So let's go ahead and put in, that's fine, 6.283, and pi r squared, pi times 1 squared, 3.141. So you can see right now that the area is in fact not greater than its circumference. And so if you continue the pattern, we can try and find out when is the area going to be greater than circumference. So if you continue with number 2, 3, and 4, you may want to pause the video and just see that you're doing it correctly. You should get this. Okay, and here you get 25.132 and 50.265. Now, again, hopefully you pause the video there, or you just take my word for it, that when the radius is 2, we realize that both the circumference and the area are equal in value, and when it's less than 2, when the radius is less than 2. So the answer is no. When the radius is less than 2, then the circumference is greater than the area. Okay? Factoring a perfect square trinomial and a difference of squares. Complete these expressions into a difference of squares. Then factor them. So a difference of squares, x squared minus 25 would be a simple one that you've seen before. And if we're going to factor this, again, the middle term must be eliminated. And that looks like this. X plus 5. Again, the square root of x squared is x, and the square root of 25 is 5. And we're going to have 1 being addition and 1 being subtraction. Okay, so in this case, x times x, x squared, and then we know the last terms, 5 times negative 5 would be negative 25. And so you just need to look at in the word FOIL, the first term is created by the x times the x, and the last term is the positive 5 times negative 5, and that's the L, the last terms. The O and the I are the outside inside. When you multiply x times negative 5, you get negative 5x, and when you multiply 5 times x, you get positive 5x. So negative 5x plus 5x is equal to 0, so they've eliminated each other. Okay, let's try another example here. In this case, you have negative 25y squared. So let's try and make the first term of this binomial a little more interesting as well. Let's call it 4x squared minus 25y squared. I'm just going to make some room here. And in this case, we'll have the square root of 4x squared. Well, the square root of 4 is 2, and the square root of x squared is x. And the square root of 25 is going to be 5, and the square root of y squared is y. And those are going to be the two terms that we're going to be using, 2x and 5y. One is addition, one is subtraction. And it's that simple for difference of squares. Complete this expression into a perfect square trinomial. So again, trinomial, 3 terms, and then factor it. Well, we know the factored form of a PST, or a perfect square trinomial, looks like vertex form. So I already know that's what my answer is going to look like. And I've got addition here and addition there, so I already know that that's going to be addition. I'm looking for, let's take a look here. So when you factor a perfect square trinomial, we take this first term, square root it. We have the square root of 9 is 3, and the square root of x squared is x. And then the square root of 25 is 5. But let's just double check that that's true. So 3x plus 5 times 3x plus 5. So now the first 3x times 3x is indeed 9x squared. We know the last 5 times 5 is going to give us a 25. But what's going to happen in the middle? We're going to have 3x times a positive 5, which is positive 15x. And then we have a 5 times 3x, and that gives us another 15x. In this case, we end up with an answer of 9x squared plus 30x plus 25. So we're going to say that this is 30x. And the factored form of it is right there, 3x plus 5 squared. It's the simplest way of writing this one. And that's it for today. Simple lesson. Look forward to seeing you in class, and good luck with your homework. We'll see you in class.